Alright students, today we are going to continue our study of perimeter and area with notes 11.3. Alright, first of all I'm going to review that perimeter is the distance around the figure and that the area is the space that's covered by the figure, so the space inside. Alright, so area of similar polygons. Now, when we have, you know that two polygons are similar, then what we know is that the ratio of any two corresponding side lengths corresponding lengths can be represented with the A to B. So here, if your printer is light, this is A and this is B. We don't know what these lengths are, but we just know that if we are going to represent them as a ratio of figure 1 to figure 2, that's going to be A to B. We can also represent their areas without knowing anything else about them. We don't know how to find the area of this one or this one, but what we do know is that the ratio of their area is, you take one of the sides A and you square it, and it's going to be compared to B squared. So A squared to B squared. So what that means is if we were able to find the area of this shape and this shape, and we set them as a ratio and reduce them, it would still equal this ratio right here. Okay, so here, this is just a Roman numeral 1 representing figure 1, and this is a Roman numeral 2 representing figure 2. This says side length of polygon 1, that's A, side length of polygon 2, that's B. So whenever we're making a ratio of side lengths or perimeter, so this one's used for finding missing sides or perimeter. So sides or perimeter. That's the ratio that we'll use, A over B. Here, area of polygon 1 would be represented by A squared, and area of polygon 2 would be represented by B squared. And we're going to use this one only for when we're finding areas. That's for area. Okay, so it'll make more sense once we start going through a few examples. In the diagram, know that triangle ABC is similar to triangle DEF. And I called this one the red triangle and this one the blue triangle. Find the indicated ratio. Okay, so here, find the ratio of red to blue of the perimeters. Well, that's hard to do because all I know is that BC is 8 and EF is 12, and that's the only information that I'm given. So I can still find the ratio of the perimeters, and how we did that before was we added up all the sides of the red and added up all the sides of the blue and then wrote a fraction and reduced it. That's what we did before. But now what we're going to do is use this information up here. We take corresponding sides and we have to make sure that they match. So here I've got the length of BC, which is the last two letters in the name, so I have to match it to the last two letters of this name, which is EF. EF. So these are considered corresponding sides. So here, if I want to write the ratio of perimeters of red to blue, that means I put red on top, blue on bottom. Red is the numerator, that's the denominator. That's going to be 8 over 12, and then I reduce that. So the ratio of the perimeters would be 2 to 3. Okay? Next, find the ratio, red to blue, of the areas. Okay, so the ratio of the areas. Now remember, that's going to be a squared b squared. So we take this same ratio, or this one over here, you can take the side lengths 8 and square it over 12 and square it. You would get 64 over 144, and then you would plug that into your calculator and get a really nasty decimal. Now remember how to use your calculator to change that into a fraction, a reduced fraction, by using the math key. Alright, and when you do that, you end up with 4 over 9. But take a look at this. Remember, this one was A and this one was B. All I had to do, since A is 2 and B is 3, is square this one to get 4 and square this one to get 9. So, it's really important to find your ratio of your sides and reduce it first before finding the areas, because sometimes the numbers get really big. Okay, so here's my ratio of my areas. Alright, so when am I going to use this? Okay, so here's a really important problem. We have, this is a STAR Tax EOC review. This is something that you would find on your STAR EOC or tax test that's coming up. Okay, you are installing the same carpet in a bedroom and den. The floors of the rooms are similar. The carpet in the bedroom cost $225. Carpet is sold by square foot. How much does it cost to carpet the den? Okay, so I have very limited information here. And the information that I'm given is just how long one of the sides of the rooms is. So here's the bedroom, and I know that it's 10 feet. This is 10 feet. Okay, and this one is the den, and I know that this corresponding side is 14 feet. Alright, so what I'm going to do is find the ratio of the areas. So first of all, find the ratio of the sides. Ratio of the sides. That's going to equal 10 over 14. Okay, bedroom over den. When I reduce that, divide by 2, I get 5 over 7. Okay, so next I want to find the ratio of the areas. Okay, well, you take this number here and you square it. 5 times 5 is 25 over this number here, and you square it, and that's going to be 49. So that was a lot easier to find, but if you forget, you can still put the 10 squared over the 14 squared and just do the math. That's 100 over 196, and see how big the numbers are? But when you put this into your calculator and reduce it, you still get 25 over 49. So it doesn't matter how you remember how to do it. You're just going to find the ratio of the areas by squaring. Okay, so now let's go on with the problem. The problem is that I want to find out how much it's going to cost. Well, since it's sold in square feet, this is the ratio that I want to use, not this one. If I was finding maybe border around the room, then I would use this ratio. But since I'm finding carpet, which is the area, I want to use this one. Okay, so the bedroom is going to be represented by the number 25, and the den is going to be represented by the number 49. Now it says that the carpet for the bedroom costs $225, so I'm going to put the $225 up here with the bedroom, and I don't know how much it's going to cost here with the den. So now you should recognize this. This is a proportion. Okay, solve your proportion by cross multiplying. 25x equals 49 times 225. So when I multiply that together, I get 11,025 Now divide both sides by 25, and I end up with 441. And that is answer choice D. Alright, next. Notice how I have all this information and they want me to find the area of D, but they didn't give me much to go on. Well, that's what this lesson is all about. So let's kind of read through this and make a list of what we know. The perimeter of triangle ABC is 16 feet. So I'm going to put triangle ABC, I'm going to put capital P equals 16 feet. The area is 64 feet squared, so area equals 64 feet squared. I don't know the base, the height, and I don't know any of the sides, but this is all I know. Okay. The perimeter of DEF, so here's triangle DEF, perimeter is 12 feet. And it doesn't give me any other information, so I don't know the area of this one. It's unknown. What we do know is that these two triangles are similar. And it says, find the ratio of the area of triangle ABC to DEF. Okay, well, I can do that with the information that I have. First of all, remember that we're going to find ABC to DEF. So I'm going to write that down, triangle ABC to triangle DEF. That means ABC goes on top, DEF goes on bottom. Alright, so ratio of the perimeters, okay, well that's just 16 over 12. 16 over 12, and that reduces to 4 over 3. Remember, the 4 represents the triangle ABC, and the 3 represents triangle DEF. Okay? Next, find the ratio of the areas. So remember, I take this and I square each one. Ratio of area. Okay, so 4 squared, that's going to be 16, and 3 squared is going to be 9. So the ratio of the areas, now let me write that out for you so you can remember where you got it from. 4 squared over 3 squared, that's going to be 16 over 9. Okay, so this is the one that I want to use in order to find area because this is squared. Okay, so I'm going to set up a proportion. I've got triangle ABC on top and triangle DEF on bottom. And that means 16 is being the 16 represents the triangle ABC and the 9 represents the DEF. What I do know is that the area of ABC is 64 feet squared. So I'm going to put 64 up here, but I don't know this one, so I'm going to put X here. Again, all I have to do is cross multiply, and without knowing the base or the height, I have been able to find the area of DEF. So cross multiply, that's going to give me 16x equals 9 times 64. So that's going to be 16x equals 576. Divide both sides by 16, and x equals 36. So what that tells me is that the area of triangle DEF is equal to 36 feet squared. And there's the first question that they asked me. I'm sorry, here's the first question that they asked me, and here's the second question. So make sure you box both questions. Alright, next. A large rectangular pan used for baking cookies. I call that a cookie sheet. So here, I'm going to draw my cookie sheet. This is my large cookie sheet. I'm going to label the sides 15 inches and 10 inches. It says 15 inches long, so this is length, and 10 inches wide, so this is width. Okay. A smaller pan is similar to the large pan. So we've got a smaller one. I'm not sure how small it is, but it's smaller. And it says that the area is 96 square inches. So 96 inches squared. I do not know the width and I do not know the length. Okay, well, it says find the width of the smaller pan. And remember, these are similar. Okay, so what's the area of the large pan? Okay, well, that times that is 150, so 150 inches squared. And we already know this one, the area of this one is 96 inches squared. So the ratio of the areas is going to be 150 to 96, and when I reduce that, I get 25 over 16. Next, I want to find the ratio of the sides, or the ratio of the perimeters, as some of you may remember it. So I'm going to call it, well, just before we do that, I just want to recall that the ratio of the areas, remember that's a squared over b squared. So your a squared is equal to 25, so a would be 5, and your b squared is represented by 16, so b would be, square root of that would be 4. So the ratio of the sides of any two corresponding sides is going to be 5 to 4. Okay? So I go back over here and I say, well, the large, I put the large on top and I put the small on bottom. Then that means that my ratio is going to be 5 and this one's going to be 4. And they asked me, what is the width of the smaller pan? Width. So I'm going to be using these two numbers here, the corresponding sides. So the large pan is 10, so that goes up here. And this one I don't know. I could put a W there if I wanted. And cross multiply. 5x equals 40. Divide by 5. X equals 8. So my width of my smaller pan is 8 inches. And I did that without knowing any of the dimensions. Okay. All right, folks, that's it for lesson 11.3.